All right, welcome to our video for the fifth concept in chapter 2. So today we're talking about solving equations again, but this time we're solving for a specific variable. So what that means is we're going to have more than one variable and it won't be the same variable. And we need to solve for a specific one. If you look down here, for example, in 61, I've got a z, an x, and an m. After this comma, the problem, I guess, is telling you what you need to solve for. So when it says solve for x, that means that x needs to be by itself on one side of the equation, and everything else, whether it's a constant, another variable, whatever else is in that equation, needs to go to the other side. All right, that's what solving for means. Remember, we talked about that. Solving means isolate the variable. All right, what variable? Well, whichever one they tell you to. Okay, so let's go up here and do our fill in the blank because I kind of skipped past that. So some equations are called literal equations. And they contain more than one variable. All right. At times, you will need to solve these equations for one of the variables. Like I said, the problem will tell you which one. Steps for solving literal equations. Very much the same as regular multi-step equations. All right. Identify the variable that you need to solve for. The problem will tell you, so there won't be any confusion. Use the inverse operations. Remember, we've been talking about inverse operations to get all the terms with that variable on one side and everything else, the terms without that variable, to the other side. Remember, we're isolating the variable. So I think the best way to understand is to just go ahead and jump right in and look at an example. All right, so let's look at 61. We have z equals x plus m. We need to solve for x. So the variable that we are trying to get alone is going to be x. So everything that is not x needs to go away from x. All right, so remember, we draw a line down our equal sign. The x is on the right side of our equation with m, but we want it by itself. So we need to move m over here with z. So m right now is positive. This is plus m. We know the inverse of addition is to subtract, so subtract m on both sides. All right. Anything minus itself, these are gone, okay? If this was 5 minus 5, wouldn't you cancel these? If this was 10 minus 10, wouldn't you cancel those? Same step here in literal equations, okay? So you're just going to cancel those out, and now your x is by itself over here on the right, and that's what we wanted. But what about on the left? Z minus m, can we do anything with that? Z and m are two completely different variables. That's like apples and oranges, okay? You can't subtract oranges from apples. They're two different things, and I hope that makes sense. So there's no combining. There's nothing you can do in here. You just need to rewrite it the way it looks. Z minus m. Okay, so x equals z minus m. That's your answer. You're done. Okay, I'm hoping this is making sense. Look at 62. I'm not going to do this one. I want you to do it on your own, but I am going to get you started. Once again, line down your equal sign. On the right side, we have x. We need to solve for x, but the c is right next to it, so that means multiplication. Use your inverse of multiply, which is to divide, so divide c on this side. All right, just a little hint to get you started. I think you can handle that one. 63 is going to be the same thing, but here it's being divided. So we need to use our inverse and multiply this c so it goes over to the left. We need to get x by itself, okay? Let's look at 64. All right. Let's draw a line down our equal sign. That's first step, always. And what variable do we need to solve for? It says it right in the problem, solve for x. Okay, so we want to get x by itself. We need to move k over here with u, all right? So right now, this is a positive k. Yeah, there's a negative sign here, but this negative sign goes with x. K is positive, so we need to use our inverse and move k over. So subtract k, all right? K minus k is gone, and we have negative x still left on the right side. So negative x On the left, we have u minus k. All right. Now, a lot of you, when you have a negative variable, you're stopping here. Can you stop here? No. You need to solve for the positive value of this variable. So how do you do that? Well, right here in front of this variable, it's kind of like there's a 1 here. Okay, so if you just have x by itself, it's like you just have 1x. So there's a 1 here, we just don't write it, okay, because it's kind of implied. So this is negative 1. How can we move that to the left side? Well, divide by negative 1. Get that negative out of there. All right, so now on the left, on the right, we have a negative divided by a negative. All this does is make x positive, which is what we wanted. So now x is positive, and now on the left side, each of these variables needs to be divided by negative 1. Basically what that means is positive divided by a negative, we're talking about u right now, positive u divided by a negative. Any positive divided by a negative is going to give you a negative answer. So now u is negative, and k is negative. So negative divided by a negative gives me a positive k now. So hopefully a lot of you are noticing that all that happened here was the signs changed for these two. It went opposite. That's all happened. All right. Let's go down to 65 and look at one that's got some numbers this time. All right. We need to solve for a in number 65. A is right here and it's attached to negative 2. So we're going to have to do some division there once we get to that step. But first, let's draw a line down our equal sign. A is over on the left, but it's got all this other stuff with it. So we want to get A all by itself. Let's start with our inverse operations. We know when we're doing our inverse operations that we need to go backwards with PEMDAS. So when you were simplifying expressions, we would do multiplication or division first and then addition or subtraction. That's how PEMDAS goes. When you're solving, you go PEMDAS backwards. So you need to start with any addition or subtraction. Where is some addition or subtraction here on the left side? Right here with 4m. This is plus 4m. So let's move 4m over there. No part of this term needs to stay on the left side because there's no a here, right? We're solving for a. None of these have anything to do with a. 4 and m, we can move those. We're done with them, right? So minus 4m to both sides, all right? 4m minus 4m, 10 minus 10, 3 minus 3, it doesn't matter, they're all gone. Subtract anything from itself and it's gone. Now all we have left on the left is negative 2a equals, we have 1 minus 4m. All right, last step, we still need to get this a all by itself, so what do I need to do? Right now, a is right next to negative 2, which that means to multiply, so let's do our inverse of multiplication, which is to divide negative 2 to the other side. Okay, so now let's cancel these out, and all we have left on the left is a equals, oh hey look, we isolated a, we solved for a, we're done. On the right side, we have 1 divided by negative 2, and that gives me negative 1/2. Then we have negative 4 divided by negative 2. 4 divided by 2 is going to be 2, and here we have a negative divided by a negative, so it's going to be positive 2. M comes along for the right, so plus 2m. Okay? All right, I want you to try 66, 67, and 68. I think that you can handle those. 66 is going to be a little bit tricky, but I want you to try it anyway. I want you to give it a try. We can always go over 66 in class if everybody had a hard time with it. And that's the point of the flipped classroom, is so that you can try the difficult ones, and then we have time in class to go over them. All right? Let's do 1 or 2 on the back. I know this video is getting pretty lengthy, but I do want to show you at least 2 more, and I don't want to neglect the problems that are on the back page. So let me look for one that's kind of nasty looking. The ones back here have 3 variables in them. So let's do 71 and 73. All right, I'm going to do these 2, and then I'm going to call it quits for this video. All right, we're going to solve this equation for x. So I like to kind of highlight the variable right off the bat so that I know what I need to solve for, or basically what I need to isolate. If you don't have a highlighter, just circle it or something, that's fine too. Okay, so I drew a line down my equal sign. I have my x over on the left side, and that's what I need to solve for. So let's move everything else around it over here to the right. All right, remember PEMDAS backwards, we need to start with addition or subtraction, so let's add 2. And we have -3 left over, these cancel out. -3x equals -r plus d plus 2. Just write it all the way it looks. All right, then divide by -3. X equals -r plus d plus 2 divided by -3, the whole thing. Now remember I told you in the last problem that I would like you to start getting into the habit of individually dividing this -3 into each term separately. Nice, you're going to have -1/3 r plus 1/3 d, positive 1/3 r, because these are both negatives, minus 1/3 d minus 2/3. Okay, you're going to just get a lot of fractions. Down here with number 73, let's solve for x again. So here's my line down my equal sign, and let me find x. Here it is. I need to get x by itself. Isolate that x. All right. So let's start with any addition or subtraction. Here I have addition. Let's subtract 1 to the other side. On the left, I have -2x left over. And on the right, d divided by r minus 1. Okay. Now we need to get rid of this -2. Divide by -2. X equals this term into each one separately, and hopefully it'll become a little bit better. Okay, we have d divided by r divided by -2. Okay, when we're dividing fractions, we can multiply by the reciprocal. So right now, -2 is like saying -2 over 1 if I wanted to write this as a fraction, correct? So if I flip that and say 1 over -2, I can multiply it by this fraction. Okay, so really what I'm going to have here is d divided by r times 1 over -2. Okay, because I took this as a fraction and multiplied by the reciprocal. All right, and then I'll have, don't forget about the -1. -1 divided by -2, 1 divided by 2 is going to be just 1/2. But we have a negative and a negative. So when you divide two negatives, you get a positive. So plus 1/2. All right, let's just do this math real quick so it looks a little bit neater. D times 1 is just d. And on the bottom, r times -2 is just -2r minus 2r plus 1/2. Okay? Now, like I said, these are going to get a little bit messy. 73 was really messy because we already had a fraction in the original problem, so things got a little weird. That's why I did 73 with you in the notes, all right? But if you look at 69, 70, let me back up, 72 and 74, none of these have a fraction in them, so you should be able to handle these. These 4 are going to look like what I did here in 71, okay? So give these a try. I know that they're going to get a little bit messy, and I'm anticipating that. We'll talk about it in class, and we'll spend more time, all right? Please be careful with this lesson. Make sure that you go slow and really pay attention to what you're doing. This lesson is a good introduction to Chapter 4 when we start talking about linear functions, when we start using the slope-intercept form, because in slope-intercept form, you have to solve for a specific variable. So just make sure that you really, really study and pay attention to what you're doing in this chapter. Okay, I'll see you guys in class.